In this laboratory activity, we are going to focus on measurement, uncertainty, and significant figures. The first part of this is pretty self-explanatory. You're going to go through and answer the questions. When you get to this question, I wanted to talk to you about it a little bit. What you're seeing here is a balance, and on the balance is a graduated cylinder. Balances weigh mass, graduated cylinders weigh volume, or not weigh volume, but they measure volume. And when you look at this, you see a camera set up here, and this is the view from that camera, so that's the side view of it. And you want to read a graduated cylinder at the bottom of the meniscus. And so as you go on down, I want to point out this part of the laboratory activity. When we look at this part of the laboratory activity, the instructions fall after it. Okay, so it says play and pause the video above and record the mass and volume at 5 different points for each trial. So when we come here, what we're going to do is there's 2 trials. There's liquid 1 and liquid 2, and we are going to load liquid 1. And so we hit play, and what they're going to do is they're going to put that graduated cylinder on the balance. And so this is our first, when we look at this is the first mass we need to record, which is 96.4. And that's what we're going to consider the total mass here. That would be the mass of the graduated cylinder and if there was any liquid. So we're going to put 96.4 here. Now you might have a different number, so make sure you record the number that you have. Now, once we do that and we see that we don't have any volume yet, we're going to put a 0 in. Then what we're going to do is we're going to let the trial progress. And what they're going to do is they're going to pour this liquid in. Now the liquid is really thick, and so you'll see that, and then you'll also see that it's got some bubbles there. Now they speed it up to let the bubbles kind of come up so that you can read the volume, and so we're going to pause that. Now, when we look here, you can see this is kind of our second volume. We're going to look and we're going to record the measurement where this is 20, 21, 22, 23. And so the smallest increments go up by 1 milliliter. So when we look at this, I would put this measurement somewhere like in between 22 and 23. And so using an estimated digit, I would say it's probably like 22.5. Okay. And so I'm going to come down here and I'm going to say, all right, my second volume was 22.5. That's my volume. Let me put the units up here. They're milliliters. Now, we're going to come back up to the top and we're going to record the mass. That's 124.1. Now again, your mass might be different, 124.1. Now, you're going to let the recording play again and it'll go to the next amount. But I'm going to stop here and show you what to do. It says, after collecting the mass and volume data, fill in the 2 fluid mass columns using the change column formula. And so what they want you to do is they want you to select here and go to the change column formula. And what you're going to do is you are going to take the total mass and subtract, right, 96.4, because we only want the mass of the liquid. So we want to subtract out the mass of the graduated cylinder. And so we submit that, and that will automatically do that for you all the way down the column. Then we want to go ahead and let this calculate our density for us as well. So this would be the liquid 1 density. And so you would come here, and when you go to column change formula, and we know density is mass over volume. So we would take the liquid 1 mass without the graduated cylinder. We divide it by the liquid 1 volume, and that's the density that we have there. We can fill in our units here. These are grams, and of course these are grams per milliliter. Now, you're going to fill in all of these columns for liquid 1, and then you're going to come up here and you're going to change your trial to liquid 2 and look at liquid 2. Now, liquid 2 has some water in it before it begins, but the actual liquid itself is a silver color. So they tell you here, you just need to ignore the water on the top and measure from the bottom of the silver color material's meniscus, not the water volume. So you're going to do that. So you'll fill both of these in, and then what you're going to do is you're going to come down here, there'll be a graph, and you're going to come down here and it says, using the graphing feature, place fluid 1 mass on the vertical axis. So we come up here to the vertical axis, and we're going to choose right? The liquid one, it says fluid one. I used liquid one when I made the table. Liquid one mass, right? And then what we're going to do is then on the horizontal axis, we're going to put the volume. So this is all for liquid one volume, okay? And what we're going to see here is 2 points there. Now you're going to have 5 points, but because you're going to do all 5. I only did the first 2. So then what you're going to do is you're going to come down here and you're going to click the cog in the upper right of the graph right here, and you're going to select curve fit, and you're going to select linear with a y equals mx plus b fit. When you do this, you should see a straight line, and this is the grams per milliliter. So then what you're going to do, right, is answer the questions about the slope-intercept formula, and then you are going to continue to answer the questions. Now, once you've figured out the density, you are going to use the table here to identify the substance in trial 1, and then you're going to come down here, right, and identify the substance in the second trial. Now, the next part of the questions are about uncertainties and errors that we have in measurement, and so you will read these and answer those, but they're pretty straightforward. As always, feel free to reach out if you have any questions.